Hey, yo, 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 it's Mr. G. This is the video for determining slope and y-intercept. So, let's get to it. What we're going to be doing today is we are going to be looking at graphs like this one right over here. And we're going to try to find a way to transfer that graph to an equation that looks like this. And the way we do that is we identify the slope and we identify the y-intercept. Now you guys might be asking, what is y-intercept? And we're going to get to that in a minute. But first thing what I want you guys to do is we're going to look at the slope here. So if I'm looking at this graph, if we notice we have two given points, okay? So at this point in time, you guys should be able to tell me what is the slope of this line by looking at these 2 points. And the way we find the slope is we use rise over run, okay? And again, this shouldn't be new. If this is new, I need you to go watch the previous video where it's talking about finding slope. Okay, so we're gonna find the slope by doing rise over run. So we always read lines from left to right because we always read words from left to right. We just read from left to right. So because I'm going to read my line from left to right, from the left side of the line to the right side to the line, from this point to this point, my graph is going down. Okay, it is going downhill. Because it's going downhill, I know my slope is a negative slope. So let's see how far down it's going though. And we do that by counting the rise and then counting the run. So if I count the rise to get from here to here, I notice it only goes down 2. Down is a negative direction. So it's going down 2 to get from this point to this point. Then the run is going to go over 1, 2, 3. And to the right is a positive direction. So the run was 3. So my slope is negative 2 of my rise over positive 3, negative 2/3. And what some of you already might have noticed is that this negative 2/3 is this value right here. Okay, so that's something we're going to be putting together here in a little bit. So now I want to talk about this word y-intercept right here. So I say we're going to determine the slope, which we already did by counting the rise and the run, but I also want to determine the y-intercept. So let's think about what that word intercept means. Intercept means when we cross something, okay? When we intersect with something. So if I'm intersecting with something or if I'm crossing something, if it's saying y-intercept, what it's saying is if this is my y-axis right here, this whole line is my y-axis, this y-intercept is when my graph crosses this y-axis. And if I look here, my graph crosses a y-axis right here. Okay, that's when this line is crossing this y-axis. And it's crossing this y-axis at the point 0, 4, or when my y is 4. And that's where we get this value right here. Okay, so to kind of summarize what we just talked about, what we're going to learn today is what's called slope-intercept form. Okay, so slope-intercept form is the format in which all of these equations of a straight line equal to. So a straight line, if we're going to have a relationship that has a constant rate of change, if we were to graph it, it's going to make a straight line. If we have a straight line on a graph, the equation is going to look like this. Okay, it is going to be y equals whatever the slope is times x plus some other number. Okay, and this plus could also be a minus, and that's okay. Okay, so it could be plus or minus some other number, and that's the y-intercept. We call the y-intercept the b. So make sure we know that y equals mx plus b. My m represents my slope. My b represents my y-intercept. So going back over here, my slope, was negative 2/3, and then my y-intercept was this positive 4. And when this is negative, let's say that the graph was crossed the y-axis right here. Okay, so I just took the same graph. Let's go up 1, 2, over 1, 2, 3. So I took the same slope here. I have a slope of negative 2/3. Okay, but I just shifted this whole line down. I have parallel lines. Shifted the line down, and let's say it started at negative 2 right here. That's when you're going to have a minus sign. My slope is negative 2/3, and then my y-intercept is minus 2. Okay, so I don't want to get a little bit ahead of myself, but I just want to show you the example of when that's going to be that way. So again, we have to find the slope and then where this line crosses the y-axis. Okay? And that is known as slope-intercept form, where m is my slope and b is my y-intercept. Now, if I was looking at this graph right here, and I wanted to write an equation, I wanted to figure out what the slope was, and I wanted to figure out what the y-intercept was. Okay. Right away, I should be able to find my y-intercept because it's where this line crosses the y-axis. The y-axis is right here, and the line crosses this y-axis right here. So what is y when the line crosses the y-axis? And my y coordinate is 2. So my y-intercept of this particular line is positive 2. Now what I need to do is I need to pick another perfect point on this line. The cool part about the y-intercept, once you find it, you have a point on your line. So now I need to find another perfect point in order for me to determine the slope of the line. So if I look here, sometimes it's tough to see, but we have to use our best judgment. It looks like the line is going to this point perfectly right here. So now I can determine what my slope of the line is because I have 2 points to count between. Okay, I can pick my rise and my run going from left to right. I can pick my rise and run from this point to this point. Okay, so my rise goes up 1, 2, 3. So my rise is 3. So my slope, I know my rise, my numerator is 3 because it's rise over run. And then my run is just 1. So it's 3 over 1, and 3 divided by 1 is 3. So my slope of this line is 3. My y-intercept of this line is 2. If I wanted to write this equation, it would be y equals whatever my slope is, that's 3 times x, and then my y-intercept is 2. Okay? So let's look at this line. Now I have an equation. Instead of having a graph, I have an equation. In this particular equation, I need to figure out just what's my slope, what's my y-intercept. So again, the slope is always a value attached to the x. Okay, it's always just being multiplied by x. So my slope of this line is negative 5 because this is negative 5 times x. My y-intercept of this line is going to be the other value over here. Okay, this little extra that's being added or subtracted onto. So my y-intercept, and it's not just 3. It's going to carry the sign with it. So because that's minus 3, my y-intercept is really negative 3. Okay. Looking again, another example. Try to figure out what the slope and the y-intercept is on your own. Go ahead and just write it down. So my slope of this line is 1/2 because that's the number attached to the x. So there's my slope. Okay. Whoop. And then my y-intercept is the extra, and we keep the sign with it, so my y-intercept is positive 3. This is a graph of that line just to show you what it would look like. My y-intercept is positive 3. 1, 2, 3. There it is. And then my slope is 1 over 2, or my rate of change is 1 over 2, because slope and rate of change are the same thing. So that means my rise is 1, and my run is 2. So that means from here I would go up 1 over 1, 2. Look, and I went up 1, there's my rise, over 2, because there's my run. Up 1 over 2. Up 1 over 2, and it maintains the same because it's a constant rate of change. The slope is constant. It's always going to be going up 1 and over 2, or down 1 and over 2. Okay? All right. So here are your steps. To determine the slope and the y-intercept. First, step 1, we need to confirm the rate of change. The slope is constant. Okay, so sometimes you're going to be given a table. Okay? And that table might go 1, 2, 3, 4, so it's changing by 1s. And I need to make sure that my rate of change is constant every single time. So then it might be 4, 6, 8, 10. So I need to make sure that I have a constant rate of change by finding my change in y and dividing it by my change in x. Okay, so my change in y here is like 2, 1, so that means that my rate of change is 2 over 1. And I need to make sure it's 2 over 1 every single time. Okay, which this one particular is. It's going up 2 and it's going up 1 every single time. So my rate of change would be 2 over 1. I also then, step 2, need to find the initial value, and that is when x equals 0. So let's go back over here real quick. My y-intercept we said was 3 right here, right? That's going to be when x is 0. Because if we look here on this y-axis, on the y-axis, x is 0 right here, right? This is the origin where 0, 0. X is still 0 here. X is still 0 here. X is going to be 0 here. X is 0 here. X is 0 here. So the y-intercept is the initial value, or when x is equal to 0. So if I were to continue this pattern, let's just keep using this table to show what I'm talking about. If I were to continue this pattern, so it went up, it kept going up 1, and then it kept going up 2. So I might have to go backwards to figure out what my x value, what my y is when x is 0. If I want to know what y is when x is 0, I went down 1. And so because my rate of change was going up 2, up 1, if I go backwards and then I choose to go down 1, then that means I'm going to go backwards and I'm going to go down 2. So then my y-intercept for this particular table would be when x is 0, my y is 2. So my y-intercept, oops, not y equals, my y-intercept is 2. Okay? I got a joke for you real quick before I forget. Why is it sad that parallel lines have so much in common? So why is it sad that parallel lines have so much in common? Here's an example of some parallel lines right here. Why is it sad that these two parallel lines have so much in common? It's sad because they're never going to meet. They're never going to meet. So sad. All right. So here we go. I want to figure out the slope and the y-intercept of this particular table, and I want to do so by following these steps. So step 1 is to confirm the rate of change. The slope is constant. So I need to confirm that my rate of change is constant. So let's see, we're going up 10, up 10, up 10. That's a good sign. I'm going up 2, up 2, up 2. Yep, looks good to me. Okay, so that means my rate of change is constant. So now I can figure out what is my slope. My slope is my rate of change. Well, it's the change in y over the change in x. So it's really 10 over 2. That is constant because it's the same thing every single time. And 10 over 2 equals 5 over 1. If I simplify it, or 5 divided by 1 is just 5. So my slope for this particular table or this particular relationship is 5. Now I got to figure out what my y-intercept is. So my y-intercept is when x is 0. So if x is 0, I need to figure out what my y-intercept is. It's the initial value when x is 0. So because I've been going up 2, up 2, up 2, and I'm going up 10, up 10, up 10, what I need to do is I need to continue that pattern until I get to 0. So to get from 2 to 0, I just got to go down 2, which means I'm also going to go down 10. Maintain that rate of change, maintain that pattern, which means this is going to be 0, 12. Okay, so my y-intercept for this particular equation is 12. If I wanted to write the equation, it would then be y equals whatever my slope is times x plus or minus my y-intercept. My slope is 5, so that's y equals 5x. My y-intercept is positive 12. So y equals 5x plus 12. Okay, try this one on your own, please. Okay, so hopefully you pause it. If you didn't pause it and you're cheating, try it on your own. You know how to do this on your own, so give it a shot, and then you can see if you got it right or wrong. So again, I need to figure out what my rate of change is and make sure that it is constant. So I do go up 7 every time, and I am going up 1 every time. So my rate of change is constant. It's change in y over change in x, 7 over 1. So my slope is 7. Going backwards, so when x is 0, I'll go down another 7. My y-intercept will be 1. So if I had to write an equation, it'd be y equals 7x, my slope times x, plus 1. Finally, last one, you might have to look at a graph. We've already looked at it once. We'll look at it again. If you have to look at a graph and determine what the slope and the y-intercept are, again, the y-intercept is whenever this line crosses the y-axis. Again, if I label this correctly, this is my y-axis, this is my x-axis. The line's crossing right here. Okay, I made that point way bigger than it needs to be, but now we can really see where this line is crossing the y-axis. There's my y-intercept. So my y-intercept is 1, 2, 3, 4, 5, 6. Okay, and then my slope then is going to be, I need to pick another perfect point on this line. Okay, I got a perfect point here. 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 I can check the slope between any one of these 2 points because the slope is constant. That's why it's a straight line. So it's going to be the same no matter which 2 points I pick. So if I were to go just from here to here and I'm trying to find my rise and my run, or my rate of change, or my slope, goes up 2. So my rise is 2. My run is 1. Up 1. So my slope is 2 over 1, which is just 2. If I had to write the equation, it would then be y equals my slope times x plus my y-intercept, which is 6. Okay, that's all I got for you guys today. I hope this helped. Please let me know if you have any questions, and good luck. Gradius out.